Okay? So when we challenged these mice, when we caused a stroke in them, we found out that they responded to stroke in a very strange manner. If we have the wild type, they get little strokes, and this is the small bar. But when we looked at the ones that don't have NOSH3, and we challenged them with a stroke, the stroke were twice as big. Look at this. Compare this to that. Compare this to that. And we did that in many different ways, which gave us the idea that when animals don't have NOSH3, and when you don't have NOSH3, it's as if the satellite was just like knocked over. It crashed landed, it's gone. And that's a pretty good indication that associates NOSH3 signaling with a stroke. Basically, if you don't have that signal, the strokes are twice as big in mice compared to the ones that have it. They still get strokes, well, because we are challenging them. It's a challenge, but they are twice as big. And we did that in two different ways. Now, we can design some experiments to really see unambiguously whether NOSH3 signaling plays a role in a stroke susceptibility. And that's what we call a rescue experiment. A rescue experiment is, well, we know the original satellite was knocked over, the one that was sent by the American team, but we can get the, I don't know, Russian team or the Chinese team to send one over to the same place and replace it. And this is what we call a rescue experiment. Okay? So this is a very good way for us to really learn about whether this signaling has to do with a stroke or not. And this is actually what we designed. I made 3 different mice, one that has the normal NOSH3, and mice that have the 2 different Columbia mutations. Okay? And then I tested them in these assays, in these rescue assays. And I'm going to tell you what we found. So, this is the data. Here, the height of this bar simply indicates how big the stroke is. And you know big strokes are associated with what? Lack of NOSH3. In the NOSH3 knockout, okay? There is no NOSH3 signaling. When there is no NOSH3 signaling, the strokes are big or small? Big. So here we don't have NOSH3, the strokes are big. If we rescue it with the normal, what happened? Smaller stroke, okay? If we now do the rescue and we send the satellite over that has this mutation, this is the mutation that is associated with the late onset disease. Look, did we rescue the stroke? It became smaller. So yes, we did. What happened with the other one? What happened when we rescue with the mutation?
Much bigger.
It's much bigger. When we use the mutation that in humans is associated with early onset, when they are very young, of a stroke, and we use that for the rescue, the strokes were much bigger. And this was for us a very strong evidence linking NOSH3 signaling to stroke susceptibility. And the bottom line is that in both mice and in humans, when you have mutations that affect NOSH3 signaling, they are more susceptible to stroke. If you are a CADASIL patient, stroke will happen in your 20s as opposed to your 40s. If you are a mouse, the strokes will be twice as big than if you have normal signal. And this is experimental demonstration that links NOSH3 signaling to stroke. Do you have any questions about that? Now, what is happening there? This one works. That's the mutation. Why does it? So we were very curious about this because this is also a CADASIL mutation and the patients get a stroke. However, this indicated that still the satellite had a little bit of capacity to work. So we were looking at the situation again in humans. What happened with these individuals? Well, they do get strokes, but they happen in these individuals much later in life. So we realized that here we were testing animals that were very young. They were 3 months old. 3-month-old mice are very young mice. Instead, 1-year-old mice are very old mice. And this is because mice don't live 70, 80 years. Mice live like 4 or 5. But in laboratory, they actually live only 2. So 1-year-old mouse is pretty old. And when we did the same analysis in mice that were 1 year old, this rescue did not happen. The values were very similar. So we're able here to reproduce in the mice the behavior that is actually happening in humans. It turns out that yes, Notch3 signal is very important for the stroke susceptibility, but it's also age dependent. And that is true in mice as it is in humans, which is remarkable. However, in both these animals, the pathology occurred. And this is like, for instance, you know how I was telling you that smooth muscle cells, these are the smooth muscle cells, they die in CADASIL. This is a vessel from a mouse, and they have